Welcome back. We're going to continue talking about finding centroids. But on this video, we're going to employ a concept we call composite bodies. So the idea of composite bodies is simply this, that we're going to, if I've got some shape here, right? So the calculus works well and good and all wonderful, blah, blah, blah. What happens if there's not really a function to try to describe this shape, right? How do we describe this shape? Well, here's what we can do is we can break this thing up and we can say, well, this is the sum of 1, 2, 3 different shapes. And what you can find is, there's no equation that I can use to describe the area of the shape. I mean, actually, it's a trapezoid. I could probably go find an equation for area of a trapezoid. But I know the area of this triangle. If I know the dimensions of this triangle, I can find the area of this triangle. This area of this rectangle is easy to find. The area of this other triangle is easy to find. The idea of composite bodies is we break a complex shape into known simple shapes. And so what we can do then is we can say, well, the area total is going to equal the area of this first triangle plus the area of the rectangle plus the area of shape number 3, this other triangle. I can find these areas easy, add them all up. That sum gives me the total area. And the location of the x bar, the location of the centroid in the x direction, how do we do that? Well, what I can do is I can say, well, you know what, let's blow this up just a little bit. If I scale this up just a bit so I can put a little more detail in this thing. Yeah, I've not drawn it exactly. Don't mind that I didn't draw it exactly right. 1, 2, 3. So the centroid of this triangle is going to be somewhere right in here. So if I say this is my origin, what I can do is I can say, well, this is x tilde 1. That's the location of the centroid of this triangle. And I would say the location of this centroid is kind of right here in the middle of this rectangle. So from the origin out to here, that's x tilde 2. And the location of the center of this triangle is down here, kind of in the thick part of that triangle. This is x tilde 3. The x bar is going to be the sum of all these x tildes times the area for each individual shape, divided by the sum of the individual areas. So this is going to be, in this case, it's going to be x tilde 1 times a1 plus x tilde 2 times a2 plus x tilde 3 times a3 divided by this total area that we've already found up here. And the same thing with y bar then. Y bar, if I find, let's say these two triangles are essentially the same shape, we'll say that this is y tilde 1, and it's also the same for y tilde 3. They're both located at the same height. And then y tilde 2 is up a little higher because it's to the center of that rectangle. Y tilde 2 is up there. Again, we're measuring from this origin here. So y bar we're going to find as the sum of each individual y tilde multiplied by each individual area divided by the total area, the sum of all individual areas. So again, just like we see here, now it's going to be y tilde 1 a1 plus y tilde 2 a2 plus y tilde 3 a3 divided by this total area that we've already found. Now, a bit more theory here. Holes or missing shapes can be treated as negative areas. That's interesting. So if I've got this shape here, so this, what I've drawn out here is perfectly acceptable. But maybe I've got this shape here. Same shape. And I say, you know what? Oh, you can't see that. I apologize. You know what? If this is my shaded area, what if I say, well, that's basically a big rectangle with two missing triangles here. So I would say the whole area would be, let's say, I don't know, 4. And we could say this is 5, and this is 6. So I would have a centroid up here and a centroid up here. So we would say this is x tilde 5. And the center of 4 is going to be right in here. X tilde 4. And then 6 all the way out here. X tilde 6 all the way out there to that little triangle out there. X tilde 6. Right? Now, keep in mind when I'm saying 4 would actually be if this whole thing was solid. This would be x tilde 4. We would say the whole thing's solid and we've removed these two triangles in here. I could treat that the same way. I would get the same mathematical values I would get if I use the same dimensions for this trapezoid, where I've broken it up into 3 positive shapes. I could say, well, I've got one positive shape with 2 negative shapes, 2 holes, if you will. They're all going to have, so let's say this is y tilde 4 here. Right, same elevation. I've not drawn it well, but same elevation. And then up here to these guys, these are y tilde 5 and 6 are up here at the same value, same point. So what would we do here? Well, here we would say the area total is going to be this A4, the area of this large entire rectangle, and then I'm going to remove these two areas, so then I would remove minus A5 and also minus A6. And then to find the x bar, I would add the positive one, so it would be it'd be x tilde 4 times A4, and I would subtract the negative one. So I've got a negative area, so you could see, you could either say plus x tilde 5 times a negative A5, since that's removed. You could also just simply, like for shape 6 here, I would just say, well, I could also say x tilde 6, A6, but just make sure this one gets subtracted. So the area has a negative sign for the holes. That's the whole point here. Holes or missing shapes can be treated as negative areas. So mathematically, plug in a negative area, and then again divide by the total area. And the y bar, we do the same way. Y bar would be y tilde 4, A4, minus y tilde 5, A5, and then minus y tilde 6, A6, and then divide by the total area. Right? If you don't believe me, feel free to say that this is like, I don't know, let's keep the math simple. Let's say this is, let's say these are 3 foot. This is 3 foot. Let's say that this whole this span here would be, I don't know, let's say 6 foot. And let's say this other triangle here is 3 foot. Both of them are 3 foot tall. They're both 3 foot wide. I could apply the same dimensions up here. I could say that this is a total of 12 foot up here, and this thing is 3 foot tall. I'm going to stop here for the night. It's getting late for me. But if you're watching, if you kept up, great work. What I would suggest is a nice simple exercise. This is pretty simple math. See if you find the same centroid following this logic. We just did for 2 negative triangles. Again, so shape 4 then has this 12 foot by 3 foot dimensions. And compare it to what you would get using this approach, where I broke it into 1, 2, 3 positive shapes, where I've got a 6 by 3 rectangle here, and I've got a 3 by 3 triangle here and a 3 by 3 triangle there. And what you need to know that. You need to know that this is 6 foot. These are what I'm saying here is this shaded area is the same as this shaded area. I'm just analyzing mathematically 2 different ways. You'll get to the same result. I challenge you to check that. All right, guys, like I said, I'm going to stop there for the night. Hopefully that gets you pointed in the right direction to get started on the homework, and then I'll finish up lecture 18 in a couple more videos. We'll work some examples either tomorrow night for me or the night after that. I'll get them up before the weekend, though. All right.